Hello, hi, this is Srijendra and this diagram illustrates the complete self-healing workflow built using OpenShift CRC, Prometheus Alertmanager, Event-Driven Ansible, and Ansible Automation Platform. The process begins when an administrator intentionally scales the Nginx deployment to zero replicas, simulating an application failure. Prometheus continuously monitors the clusters and evaluates a custom Prometheus rule. When it detects that the deployment has no available replicas for more than 1 minute, it generates a deployment down alert. The alert manager then forwards this alert directly to the AAP External Event stream over HTTPS. So using the public route of the AAP developer sandbox, no ngrok tunnel is used for alert delivery. Then event-driven Ansible evaluates the rulebook synchronized from the GitHub, and if the alert matches the configure conditions, it triggers an automation controller job. The job template executes an Ansible playbook that connects to my local CRC cluster through a secure ngrok tunnel because the Kubernetes API is running locally. The playbook automatically scales the deployment back to the desired number of replicas, restoring the application without any manual intervention. Finally, the Prometheus detects that the application is healthy again, the alert is resolved, and self-healing application process is complete. So, before implementing the self-healing workflow, I first configure OpenShift monitoring stack on my local CRC cluster. By default, workload monitoring is disabled in CRC. So I enable monitoring using the CRC config set enable cluster monitoring true. When I do CRC config, then it will have a enable cluster monitoring true. After that, we need to do CRC stop and CRC start. So this enables a cluster monitoring in local OpenShift CRC. Next, I created a cluster monitoring config in config map in the OpenShift monitoring namespace. This is the OpenShift monitoring namespace, and I created a config map using enable user workload true. This automatically deployed the Prometheus user workload, Prometheus operator, and Thanos rule components in OpenShift monitoring user workload monitoring. After verifying that the monitoring components were running, I created custom Prometheus rule. So I created a custom Prometheus rules in the demo namespace to detect any Nginx deployment had a zero replicas available for more than 1 minute. I also configured alert manager config. For that, with the AAP external event stream webhook URL and basic authentication credential stored in Kubernetes secrets. So I finally update the alert manager configuration to discover alert manager config resource from my application namespace. At this point, monitoring stack was fully configured and ready to send alerts directly to the Ansible automation platform whenever the application failure is occurred. So this is the architecture summary that I explained earlier, and this is the one I did the configure CRC set enable custom monitoring true. So once we do this enable custom monitoring, then we will have a number of pods get restarted, like alert manager main, Prometheus, OpenShift state metrics, node exporter, Thanos. These are those pods will start running when we set the cluster enable custom monitoring true. So after that, so we will create a config map for our local workload monitoring. So we already have a namespace OpenShift user workload monitoring. So for now we have a Prometheus gates and alert main, Prometheus operators, kube state metrics. Now we need a Prometheus user workload, Thanos user workload, and Alert Manager user workload. So this is the config map that we'll be creating, and it will be enable user workload true. Once we apply this, then we will have a this user Prometheus user workload and Thanos rule user workload pod will be start running, and this will enable our monitoring our Nginx applications. So we will also create a secret for the connection to our EDA using a alert manager config mess. Uh, so using this alert manager config for the EDA, and so we will have a alert manager config once we have created the config map. So alert manager will only use an alert manager config for alerts that originate from the same namespace as the alert manager config. So that's the reason we'll create Prometheus rules and alert manager config in those demo namespace, because once we create the config map, it will have a on namespace. That means alert manager config match strategy is on namespace. That means those the alert it receive where it is has configured those like Prometheus rules. For demo namespace, we need capture the alert for those Nginx deployment. Then the Prometheus rules should be configured in that demo namespace. This is manually deployment Nginx to replica zeros, and once we deploy it, there is no resource found in the demo namespace. And to view the Prometheus rules, we need to forward OC for port forward, so that we can see in GUI that the deployment is down. After that, we'll upload alert manager main. So since we are having alert manager config match strategy on namespace, we also need to have a alert manager config selector and namespace selector, so that it is able to send the alert to that particular EDA that we have configured. For that, we need a manual patch that I have done. So upon restarting CRC, this file will be automatically get deleted. So we need to patch again in order to send our alerts to the EDA event. So this is a sample Nginx deployment for scaling up those deployment. And this is the Prometheus rule that we have created in demo namespace. This is the deployment down, and this is the rules, and this is the summary. And this is those alert manager config that we have created for sending the events to those EDA, and we have configured webhook, and this is those URL that we have used, and this is those credential for that we have stored in the secret manager, that is EDA secret and passport. So once EDA has received, then you will see something like a EDA test. This is the name, and this rulebook should be activate and running stage. So once it receive any events, then we'll have it will go to match to those rulebook.mls. So this will be those ml file for the rulebook, where we define the source and we define the condition true. For simplicity, I have used the condition true. This is the one where we need to validate what condition do we need to match, like for any application down or pod crash loopback, and based on that it will execute the job template like EDA test. and and source means that what which port that is listening, and for this source we can get over here while configuring the event streams, where it is defined as Ansible EDA PG listener. and this is the one we receive those events in the event streams. This is the log file. So once those event is streamed, it and execute the playbook called EDA test job template, and this is the one we receive a namespace in those nginx deployment scale up. So this is those logs in ngrok, and once it is received, uh, send those nginx scale up, then we can have a OC get pods, then the pods are running. So thank you for listening. So for part 2, and I will give the demo, so how I configured all these things. So see you next time in part 2. Thank you.